So, anyone have any doubt from last session? Anyone have any doubt? No response? No doubt? Okay. So, regarding that tool, so did you check and download the tool? Everyone? No or yes? No response? So, for that VHDL, all of you, okay, which tool? Okay. So, you are not sure? What about others? I see only two response. Okay, so let me tell you. We have two options. Either we can go with that online tool, which is this EDA playground, and in that we can select this test bench plus design language as VHDL. Okay, and you can select the tool and simulator. So this is the one way by which you can run. Okay, here you can write your design and test bench. So I will use this tool, or you can download the application also. Okay, so for that, let me tell you. So you can download that uh, Intel that oh, 1 minute. Okay, you can go to that intel.com. Here you can go to the product, and you will see. Yeah. So this uh, Quartz time you can download from the Intel website, and here you can see there are three versions. So Pro, Standard, and Lite. So you can go with the Lite version because it's a free available. Okay, then that is sufficient. So you can go with this. If you go to this Lite, okay. So let me click here, and you can just provide the ask. Okay, and here you can see we have the download option, and you can download that. So download and install instruction. So here you can see it's the light edition, and download. You can download. Okay. And for the version, so latest version is not required. You can go to some one two version back with respect to latest, so that you can download. Okay. So from here you can select the version. This is latest. So latest is not required. Okay. And this prime is also not required. You can go with the light. You can go with the light only. This light, and operating system you can do this window. Okay. And instead of latest you can go with this one two back. So 23 and something. Okay. And yeah, FPGA development tool. So Quadcom light and this. So now you can see the option here, installer, multiple download, individual download, and additional software. So you can go with this multiple download actually. So that's I believe collectively it will download all the required things. So the size is 6.7 GB, so that you can download. And if you go to other option, so that's also fine. But there are more than one file. So this, I mean, different file you have to download. But if you go to multiple download, so that alone is sufficient. So you can click here and let's see. So downloading will start probably. Let's see. Yeah, so it's starting, right? You can see it's starting. So anyone have any doubt in this uh, software download? So after, once it will download, I will tell you how to install that. And after installation, I will also tell how to use. Okay. So it's your choice. You can either go with this software or you can just go with the online tool, which is EDF. So both are sufficient. Okay. So let's see. Anyone have any doubt? No doubt. Okay. So if you are not having any doubt, we'll go. Oh, I cannot see the comments in Agile Live. Okay. So which tool? Modelsim, right, sir? No, sir. So Modelsim also you can go if it is supporting that. So that's also fine. Let me check if I have Modelsim. Modelsim. Modelsim I have. So yeah, that's also fine. Okay. So that's also fine. So maybe this is not sufficient for the synthesis or netlist. Yeah, this is also fine, but okay. So you can go to this jump start and we need to create a project and the project name, let's say the first project we will start with the data type. Okay. Data type or we'll first see the entity and the architecture declaration. Okay. So those we'll see. So first let me give the data type only. So data type, let's see. So from here you can see add file as a type. So this type should be VHDL. Okay, and file name should be data type. Yeah, you can give this file name and you can click here. So let's see. Uh, yeah. So this is the file. Okay. So here you can start. One second. Yeah. So here you can start your codes and you can start practice. Okay. So I will explain the basic supporting keywords and how to comment. Okay. And the data types and all those things. Okay. But first thing we'll see is data types only. So let me just give you idea about the one basic code. Then I will tell you one by one the data types. I will start like STD logic and Boolean, integer, enumeration data type, then arrays, then how to use them, okay, and operators, then and so on. We'll go ahead. So 1 minute. We can start. So first thing is some inbuilt thing we need to take. So I need to write here library. As I mentioned yesterday, so that software is nothing but a set of libraries. So we need to use some set of library and IEEE dot. So that STD logic. So as of now, you should not worry about what is this STD logic and all those things. So that we'll see later. Okay. Uh, So as of now, you should target. I just want to show you one basic code. Basically, we are having understanding of this tool, how we'll use this and how we'll run. Okay, so STD logic and this 1164 dot all. So this is the requirement which we need from the library. Now, now we'll start our anything we can do here, but I will go with the very basic declaration, and I want to show you how we'll run that over tool. Then we'll go ahead with the data types, and then we'll have understanding of the syntax, commands, entity, architecture, and all those things. Okay. So as of now, you should not focus on what is this entity, that I will explain later. Okay. So entity, and let's say this is data type. So data type is checking. Yeah, data type is. Then we can have a port. So the port we can give a in of STD logic type. Then we can give yeah, b as a out of STD logic type. STD logic. Okay. 1 second. Yeah. And here you can end this entity. So end of this data type. So I will tell you this VHDL is not case sensitive. Okay, so all those things will learn, but this is just I'm showing you one basic code. Okay, so that you can start on the tool. Now, what is this architecture? I will tell you later, but we are just targeting the how to create file the tool. Okay, that's why I'm writing. So architecture. Yeah. So architecture, and here we can write the behave of this entity. So it's kind of a test bench. I will explain all these things later. No worries. So behave of this data type. Okay, each, then begin and end of this behave. All right. And here I can just give, I can assign the value of B, sorry, A to B. Now let's see. So what are the steps we need to follow? So first, this program should compile. Okay. So for the compilation also we have two options. Either we can click on the compile here, or we have some symbol also. And even we have command also. So I will tell you three ways. So you can click on the compile, then compile all. Let's see. So here we can see failed. So we are getting two errors. Oh, so this I triple E. Oh, I said this double E. Huh? Where is I double E? So this one. It should be triple E. All right. Let's see. So now we can again compile this. So here you can see this is compile of data type.vhdl was successful. So it's a successfully compiled. Okay. Now we need to simulate this. Now we need to simulate this. So start simulation. Start simulation. Okay. So here uh, we can see this is the data type. So here you can see this is successfully simulate also. Now we need to run this. We need to run this, and we can see the waves here. 1 second. Yes. So let me pull this. 1 minute. Uh, where are the signals? 1 second, guys. So these are the inputs and outputs. So we can drag these to the waveform. Yeah. So now we have with the waveform this A and B. Okay. So now we can see this. 1 second. Yes. So here you can see because we are not driving anything on the A or B, so that's why nothing will come. So let me give some force value. Okay, let me apply some force value here. Some force, or we can apply some clock here. Okay, so let's see, and let me make a run. Uh, where is run symbol? So this is for the compile. 1 second, guys. Okay, let me run from here then. So let me run all, and let's see. Oh, already. 1 second. So where in the console we can see. Let me. Yeah. So here, yes. Can we see this? 1 minute. Yeah. So can you see, guys, here? Here, what is happening? Whatever I applied to A, that everything is coming to B. So the same I targeted while I wrote the code, that was B equal to A. So later I change it to not, and let me rerun this. Then this should negate. Okay. So then this should negate. So let me just uh, uh, 1 second. Yeah. So let me the simulation again. To wave. 1 minute. So through command line also we can run vshim tb vshim. some vshim data type. Uh, or not working. Okay, let me compile. Then yeah. So can you see? No, it's still same. Huh? Let me run. Yes. Um, Still it's same, no? Why it's same? One minute, guys. So why this is not reflecting? Actually, I'm not used to this model sim. That's why. If you will see this code in uh, that tool, immediately it will reflect. Okay. Fine. Then why not? 100 is working. It should come immediately. Okay, so let uh, 1 minute. Let's see in the so as a new project. So quit from sim. Uh, so here this it saved save right. That is I save it. Start. Yeah. So all right. I believe that was not saved. So can you see, guys? So here we can see the negation, right? And if I will make this instead of run 100, let's do run of 500. So you can see clearly, right? So basically, what I want to show you here, so like that we will use the tool. So whatever we will write, and then we will get the waveform. But I don't believe this model sim is enough, or this is sufficient to see the net list. So that's why I ask you to download the tool. So that was already in process in my system. So once it will download, I will show you the synthesis also. Okay. So now we'll start. So anyone have any doubt up to here? So you can use the model sim also if you have. Yeah, Vivado also you can use, but let's see if that is sufficient for synthesis or not. Okay, that is the main thing. Clear, sir? Okay. So let's start. So yesterday we discussed regarding this FPGA and this VHDL, how they are having a relation and how we'll use this VHDL in FPGA. So later on, after getting netlist, so with the help of other software, we need to convert that netlist to bit stream, and then that bit stream can be burned into our FPGA. So then the same FPGA board can be work as that design, whatever we design in the VHDL language. Okay, so let's see next. So what is next in this? So what is next? So actually, some syntax or whenever we are learning any language, so we should know a few things about that. Okay, so I will tell you those. So first of all, VHDL is not case sensitive. So first of all, VHDL is not case sensitive. Okay, and one more important thing in the VHDL. So if you want to use some comment, so command you have to use for command you have to use this dash dash. For example, if you see in our existing, okay, I will use EDA for that. Okay, the same code I will pick in the EDA because it's very easy. So here you can see even this dash dash, right? So this we are using for the command purpose. So I will save and I will run. Let's see. So here also, if you are using EDA, so you should select this VHDL. Okay, and here you can see the top entity. So in the top entity, this name should be available. So you can see, I didn't put, I mean, I need to change the entity name as per this. So I need to write here data underscore this type. Okay. So now I should rerun and then it will work. So you can see here, you are not getting, I mean, in the console, we are not getting any display message. Okay. So if I will write here, if I will write here, uh, uh, I am from behave. So it will throw an error. So you can see it will throw an error. But if I will put dash dash here, so basically here I want to show you how to comment anything if you want. So then you can see. Right? So you can see now you are not getting any error related to that. Okay, just a second. Actually, all right. So what is next thing? So it's a not a case sensitive. Now, what is the meaning of this not a case sensitive? So let's say if I am writing here entity, or if I am writing here this in the capital caps letter TY. So let's see. So are you expecting some error here or not? So can you see we are not getting any errors, right? No response? All right. So that is the meaning of it's not a case sensitive language. But if we'll talk about the Verilog, so that is the completely case sensitive language. Clear, sir? So let me make some comparison also here. Okay. So what is in this? Okay. So that is, you can say, strongly type, or I mean. Let's say and this I will discuss later. Okay, so let me cover this. Okay, so for this, whenever you are writing a program, so in the VHDL, it should have two things. One is that RTL code, and another one is that behavioral. Yeah. So behavioral code. So if you see in this case, in this our case, so here I'm writing this name as a behave. Okay. But what is the meaning of behavioral here? So it's kind of a test bench. It's kind of a test bench. So basically from here we'll drive some value to the variable and we'll check the behavior of that RTL. Okay, so like that we are planning. So RTL means that register transfer level. So it's a kind of that DUT you need to design and you need to write the behavioral code for that. Okay, so we'll write one by one. First, we'll do some basic programming, and then later we'll do a very good 2 3 projects also. Okay. Okay. And one more thing. So when we discussed about FPGA, so let me tell you the FPGA design flow also. So here, and then we'll start. Okay. So design flow also. 1 minute. Yeah. So what should be the step? So first, we should have the specification, right? So first we should have the design specifications. And then the next step we need to write the VHDL design for that. Okay. And then with the design, we need to write the test bench also. That is the behavioral. Okay. So the test bench also. So for this only, I am saying this is RTL plus behave. Okay. And then after this, next step is we need to simulate and test your design. So that is with the help of that tool we are doing. Oh, okay. So up to here we already did. Now in the Modelsim, but the next thing is we need to generate the netlist. So that I will show you in maybe after downloading the tool. Okay. So we need to generate the netlist. Okay, from that synthesis tool. Okay, and then we need to use that netlist, and we need to perform that placement and routing, and we need to optimize that. Optimization we need to do, and after that uh, uh, we can burn that bit stream to the FPGA. All right, so we can program the FPGA. So FPGA program means we can burn that bit stream, converted bit stream into this, right? So, yeah, all right. So now, before starting the uh, mm, uh, data type, so first you should know what are the basics of this VHDL. We are having entity and architecture, all those things. Okay. So let me just cover here. What we covered is we are using this for the. So this is VHDL design. Okay, and TB means test bench. Okay, so we need to use this double. Now, so we are having keywords also. So where VHDL keywords are reserved. For example, we are having entity, okay, etc, and then architecture, and then all those things. Okay, so now when I said VHDL is case sensitive, so it means that is if I am writing something name or name name, all are same. Okay, and in every programming language we have some identifiers also. So what is in the VHDL identifier? So identifier is just to identify something. I mean, it's kind of a name of a design. It's like that. Okay. So we have some rule for this identifier. So those identifier must start from letter, from letter, and can be followed by letter and digit. Letter and digits. Now, if you want to understand this, so So in our code, if you see what is this data type, so it's kind of an identifier. So it's starting with letter and followed by letter. but I want here, let's say at the rate. So let's see, will it work or not? Let's see. So what's your expectation? So you can see here, immediately you are getting error. And what is the error? Expecting an entity name. Okay. So it's not a entity name. So I mean, identifier cannot start with this. So it should be start with letter only. So let's see if I'm writing 1 1. So will it work? And here also let me write 1 1. And you should have guys LRM also, VHDL, LRM also. So here also you can see, okay. So it's not accepting the identifier. So that's why I kept a note. So all identifier must start with letter, but after that they can have digit. Let's say if I will writing here type underscore 01. So now is it acceptable or not? Is it acceptable or not? So let's see. Oh, oh, here also, right? 01. What happened? Oh, here also I need to change. Correct? So you can see it's working. It's working, right? Now next what you should keep in mind while you are defining the identifier. So they should not have the space. So space are not allowed. You can put underscore or something for the readability, but you cannot put space. Okay, and as I mentioned, the keywords are reserved. So identifier cannot be same as the keywords, or basically you can say keywords cannot be an identifier. Keywords cannot be used as identifier. Okay. So anyone have any doubt up to here? Anyone have any doubt up to here? No response? Okay. If no response, then we'll start. So then we'll start our first chapter. That is, so that is, so signal, why it is giving. Okay, let me write here only signal and data types. Okay, signal and data types. चलिए, all right. Okay, so first we'll see the signal basic. Signal basics means in the declaration, what things you should keep in mind, and what is the basically syntax. Okay, so signal declaration syntax. There is a
Yes,
syntax
sir.
that you should follow. Yes.
Yes, sir. Sir, actually, I put my doubt in the chat box as well. I just wanted to know that, sir, why do we use VHDL and how is it fundamentally different from Verilog?
Okay. Okay. So 1 minute. Then I should put here. Yeah. So this is VHDL and this is Verilog. This is Verilog. So try to understand initially VHDL was there, Verilog was not introduced. So that is the thing. So that's why we can understand first thing is lots of things should be optimized or should be good in the Verilog. But that doesn't mean both are not powerful or both cannot be used for the uh, designing purpose. So both are HDL. As you can see here, HDL, VHDL and Verilog HDL. So both are HDL language and both are powerful. Both can be used for the designing. But the thing is, in VHDL and Verilog HDL, the things when you are designing the library, the keywords, the format, everything is different. So you will get lots of benefit when you will move to the Verilog. So for example, if you see, if you go with the VHDL, so it is having a unique code style. Unique code style means uh, the coding style won't match any high level language. Let's say C, C++. So VHDL is not similar to C. But if we talk about Verilog, so it looks like C language. I'm not saying it's same, but it looks like. But that VHDL is having a very unique style. Okay, because it's in first HDL. So now if we'll talk about code. So if you'll go with the VHDL, so it's a powerful and you are able to design, but your code will be bulky. So you will have the bulky code. And with the Verilog, you can have the simpler code. You can have the simpler code. Okay. So this is one thing. And other than that also, in VHDL, you need to write lot of things. I mean, it's not concise. It's not crisp. So this is having high verbosity. This is having high verbosity, and this is having a more concise. Now you might think, sir, you are telling difference, but you still didn't answer for what purpose we should use VHDL and for what purpose we should use Verilog. So the answer is we can use any of them. So both can be used for the same purpose. But how they are differ? Because Verilog comes later. So definitely it should have some good things. Like the understanding of Verilog is very easy if you already know C. It looks similar to C. That is the one point. So there is a bulky code. There is a bulky code if you are writing in VHDL. But the coding might have simple if you will go with the Verilog. So even let me show you here. If I will go with Verilog, so the same code how I can write. I can just write module TB and module. I can just write module TB and module, and I can just write assign B B equal to A. That's all. So that's enough. That's enough in Verilog. So both are same. Both are same. But you can see here the code is bulky. Here code is concise. But both are representing one and same thing. Both are representing one and same thing. Okay. So like that. But that at the same time, that doesn't mean both are not powerful or both cannot be used for the designing. Both are powerful. Okay. So So let's say you want to have a delay. So you need to write wait for 10 ns. But here you can just put hash 10, hash 10. So like that, this is kind of an example. This is kind of an example, whatever we show. So I hope you got your answer. Clear है? चलिए, all right. So anyone have any other doubt up to here?
Sir, sir, I have joined today in this class. Sir, we are discussing all things are in FPGA using VHDL or Verilog.
So in this session, I will not talk. I will not teach the Verilog part. So we'll only see FPGA with the VHDL.
Okay, that means we are using all things using VHDL only.
Correct. Correct. Does it answer your question?
Yeah, okay, sir.
Okay. All right, guys. So signal basics. So first we'll see the signal syntax. Okay. So for the declaration of any signal, you need to write a keyword which is signal. Okay. Then you need to give. Then you need to give signal name. Then you need to give signal name, and then you need to put this colon, and you need to give the data type. You need to give the data type, and then you need to put this semicolon. So this is the syntax. This is the syntax. And if you want to, so this is only the declaration. This is only the declaration. If you want a declaration plus initialization, if you want to give some initial value, so that is also possible. So what you have to do, the signal and then signal name, then signal name. Okay. Then you can put the data type. Then you can put the data type, and you can have equal the initial value. So that value initial. So initial value, right? So this is having DAC plus initialization. This is having DAC plus initialization. Okay. So now let's see. Yeah. So let's see same in the code, in the code here. So let's say I want to add some signal. Yeah. So let's say if I want to add some signal, so what I can do, here I can just write signal. I can just write signal, and then I can type the signal name. So signal name could be, let's say, signal underscore A. So this is signal name. Okay. And here I can declare the data type. So which is STD logic. Let's say I'm using STD logic data type. Okay. So this is the same which I followed. This is the same I followed. Okay. So now let me show you. So I want to comment this. That's why I will put 2 dash here. So now let me show you. Let me run this code and see. So here you can see there is nothing in the output. So I want to show you the default value of this signal, and I want to override that value. Okay. So let's see. So let's see. Let me remove this. And let me remove this also. Okay. Yeah. So now I will add here process. ये भी हटा देते हैं, and this I want to put here for the better readability. Yes. Okay. Hmm. So process. Don't worry about this. What is this process and all those things that we'll understand later. Try to understand whenever I am teaching you. So just focus whatever is written on the slide. So let's say if we are focusing on the signal basics. So as of now, you should only focus on the signal thing. You should not focus on the rest of the things. For example, this process, this begin, this end, from the, where this came and all those things. For example, when I was explaining about the Modelsim, so at that time you should only focus how to create project, how to compile, how to simulate. You should not focus on the signal name. Now you should focus on the signal name. Okay, so one by one we'll understand. Chaliye. So, and here we'll do the end process, begin and end process. So in this, I want to print, I want to report, I want to report the initial value, the initial value, okay, initial value of this signal name. So report, what I can say is, uh, so signal A default value is, and and I need that std logic image of that sig A. So you should not worry as of now what is this std logic image. So believe me, this is just I am writing to print its value. Okay, to print the value of signal A. To print the value of signal A. Uh, result me. Oh. I'm not putting anything to end this. So that's why it's going to the maximum. So don't worry, because it's a process, right? So that process is running every time. So I can put here wait. I can put here. So it will wait here. Yeah. Yeah. All right, guys. So just focus on these two lines. This is the first line. This I am getting from this report, and the second line. Okay. So this I am getting from this report. So what is the meaning of this U, guys? What is the meaning of this U? So U is the default value of this signal. So for example, if you are taking any variable, so that variable is having a default value. Okay. So for example, if you are taking a cup of tea, so what is the default value? What is the default storage of that cup? So what is the cup having? So cup is having air only, correct? So a cup is having air. So similarly, if I am talking about the signal A default value, so what is I am getting? I am getting U. So U is indicating uninitialized. Okay. So if you want, you can you can override the value also, and after that you can put. After that you can print. Sorry. So signal A, you can put some value. Let's say one. Let's say one. And again you want to print the same thing but with the updated value. So instead of initial, you can write updated. You can write updated. Oh, then uh, 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 uh. Oh. So immediately we are printing. Actually, we need to wait for some time, nanosecond. Okay. So it's a synchronization issue. Yeah. Can you see, guys? So initial value for that signal was U, and later on the updated value is 1. Clear, sir? No response? Okay. So what you have to understand? You should understand how we are declaring, how we are declaring the signal. What is the syntax actually? So this is the syntax. So this is the syntax. Okay. And this is actually declaration. So anyone have any doubt up to here? You can ask. Anyone have any doubt? No doubt? Chaliye, all right. Okay, someone commented. What does the U value mean? I already said, right? And don't worry, this will understand in a data type. Okay, so just next to this, I will discuss this only. So we are having lots of possibility of this STD logic data type. Okay, so this is one of them. U means that uninitialized. So we can do the assignment also. So for that also we have syntax. So signal assignment operator. So operator. So for that we should use. So for that we should use less than and equal to. So this is actually indicating the direction of assignment. Okay. So for example, sig A can have less than or equal to sig B. All right, guys. So this is the syntax. Clear? So this is signal assignment operator and its example. So now we will discuss on the data types, and I will answer this question what this Gargi asked. Okay, what does this U value mean? Okay, so actually there are lots of possible value for that data type. So this is one of them. So next is, yeah. So let me give example for this assignment also. So let's say if I am having signal B, let's say if I am having signal B, okay, and after this what I am doing, sig of B, if I am assigning sig of A, and understood, guys, those, sorry, this sig underscore, when I'm writing AB, so it's not a syntax. The name could be anything. Even it could be simple A comma B. Even it could be A comma B also. Okay, so don't think like it's a syntax. Sig underscore is not mandatory. Okay, so now let me print here sig b also. So what is your expectation, guys? Can you unmute and tell me if I will print this sig b from here? So what value I should expect? No response? Can you unmute and tell me? No response? So what we are getting here? U. Why we are getting U? Because we didn't give any delay. Clear, sir? So now you can see here, you should get 1. So you are getting sig A and sig B 1, 1. So it's not the default value, it's actually updated value. So this is actually the updated value. Clear, sir? No response?
Excuse me, sir.
Yes, please.
Yes, sir. Sir, if we remove the wait for 10 nanosecond statement between, yes, sir, exactly this one. Then for B, we'll get the updated values uninitialized, right, sir?
See. So whenever, oh, sorry. So whenever you are going without delay, so actually there is a lot of things which you should understand with respect to synchronization. So that should not disturb. So if you are not getting, then it may leads to the synchronization issue. So you can see here we are not getting 1 because at the same time you are giving. Okay. So that's why either you can give a very minimum delay, but the delay is required, right? As it is considering at the same time the same value. Basically, it is not picking the updated value. Correct? So even if I will remove this weight also, so for both we'll get that U only. You can see. So that will understand at very later stage about this synchronization. You can see.
Sir, and this less than equal to is the non-blocking assignment, right?
No,
So
no, no,
whenever
I don't know. I don't know which assignment it is. What I said when I'm explaining anything, so I should focus on, or sorry, you should focus only on that particular thing at that time, because you might know what type of assignment it is, but others don't know. Okay, so we should go in the flow itself. But at the last, you can discuss anything. Okay, but at this time, so this program is to only understand the declaration and this assignment. And only up to here you should think as of now. So one by one we'll go ahead. Now I will talk about the value from where this U come. So in the next slide you should understand only that topic because it's a language. It's not like collectively we can understand in one go. Okay. At the same time, it is not like that only one part we can understand. So whenever we are learning any language, so we should focus on one by one thing. Okay, so at the same time, we should get clarity only in the one particular thing. Then collectively we should understand. So about those things we'll discuss later. Chaliye. So now the next thing should be the data type. And in the data type, now you should understand what is that U. Okay, so all those things. So 1 minute here, I should put the signal. Uh, oh, I pasted twice. This. Oh, then this is not required, right? So here, I will write here now that data type. Okay, so in that data type, we'll see STD logic. So STD logic is the data type that we'll see. So STD logic that represents the value of single bit data. So basically, I want to convey here. It's a the how many bit wide it is. It's only 1 bit wide. Sir, every data type is having 1 bit wide. Answer is no. If we'll talk about integer, so that is not 1 bit wide. If we'll talk about array data type, that is not 1 bit wide. Okay. So with respect to that, I mentioned this. Now, this is not uh, I mean inbuilt. So that is inside a package. So that package name you should know. And if you are using this STD logic data type into your code, so every time that package you need to include, you need to take into your program. So STD logic data type is inside STD logic 1164 package. So see here, I already included this. Okay, and that's why I said whenever whatever we are learning, we should focus only that particular point. So now you should focus on why we are having this. But if you ask the same question in yesterday's session or in starting of today's session, so what I should answer? Whenever we'll talk about this, at that time you should get clarity. So now, if you're not having clarity, so ask, and you should have 100% clarity in the current topic. Okay, all right. So now next thing is STD logic. So how many value or how? Yeah. So how many different type of values we can store into a variable which is of STD logic type, and what are the meaning of that? Okay. So as the name suggests, it's a logic. So mainly in the design, we are using this data type only to store 1 and 0. So only to store 1 and 0. And majorly we'll use this only. Okay. So majorly we'll use only this only. And this is for logic high and logic low. Logic low. Now we are also having Z. So Z is also supported by this STD logic. So what is the meaning of this Z? So Z is also a state, right? Which is for tri-state. So tri-stated value. So tri-stated value. Okay. So if you are good in digital, then you should know what is this tri-state value. Okay. So this is for that purpose. Now, if I'll talk about that U, so what Gargi asked. So U is uninitialized value. Uninitialized means undefined, or you can say, I mean, undefined is not the proper word. Uninitialized is the proper word, but you can say it's not updated value. It's a default value basically. So uninitialized, uninitialized value. Okay, so it's uninitialized value, and we are also having that X. So that is uh, a unknown. Okay, that's a unknown. So other than that, actually, we are also having H, H and L, H and L also we are having. I mean, it supports, and it also supports the W, W. So if you are good in the digital, or I should say that CMOS, okay. So then you should know we have weak high and weak low also, that is pull up or pull down signal, and weak unknown. So it's for that purpose only. Okay. So weak high. And if you do not know about this weak high and weak low, so you can ignore this, or you can understand after this session. That's not a part of our VHDL. But I believe you should know. Okay. Now, so this is a weak unknown basically. Chali, all right. So from here you can understand, or you can relate this program. So initial value you get the U, and when you updated 1, so then you are getting the updated value. All right. So anyone have any doubt in this, you can ask. Let me see the comment. Okay. Chali, all right. So if I see my
Could you
download,
could you please add this code also to the PPT?
what do you saying?
Could you please add this code to the PPT also, sir?
Yeah, okay. Don't worry. Yeah. Okay, all right. Yeah. So actually, from the first session and till the last session, we will have this code. Don't worry. So either I can provide you this code separately, or even at the very last. Okay, you can have all the code. So it's your choice. But why I'm not putting every time this code, because then it will be repetitive, right? But let me put intermittently. Okay, this. Then let me add the Z value also. One more value I can add. Okay. So okay, for the signal B I can add. Can I add? Can I add here Z? Z. Okay, it will be good, right? Mm, 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 Name and identifiers. What happened? So, oh, so then, oh, it's expecting that. Huh? Okay, so let me put this. This okay, yeah. So I can put as a program, no issue. Okay, all right, guys. So we have to make this. Let's just use this degree. This. All right, all right. So now, if I see my downloads, so I can see that that's completed, right? So it's completed. Let's see. So what you can do? Oh, install. So we have to install that. 1 minute. Where is the application file? Oh, this is Linux. I selected wrong. I changed. I remember. Oh, when I change the version, sorry. So it should be window. When I change the version, actually this also get reset. So let me re-download this. Okay. So now let me recheck. It should be light. It should be last version. It should be window, and it should be tool. Okay. So let me again download this. No issue. Okay. Let me delete this. Okay. So now what is next, guys? So anyone have any doubt up to here? Shall we go ahead? Shall we go ahead? Okay, let me go ahead. So now we'll see STD logic, STD logic vector. Actually, my plan was to add all the data types or at least cover the STD and then I will put, but no issue. One more thing. Yeah. So now we can go with the vector, STD logic vector. So what's the different in this vector? that will understand. But when you see the vector, now you are able to relate why I wrote this first line. Because STD logic is of only 1 bit wide. But if you want more than that, okay, you want wider. So you can make the vector also. So that is also allowed in VHDL. Now what's the syntax of that? And I will show you. So the syntax of that is very simple. You can have the signal. Then again, you can have the signal name. Okay. And then again, you can have STD logic, which is a data type. So now the data type should be STD logic vector. And here you can put the vector, for example, n down to 0. So what is this n is indicating? So this n is indicating the length of that vector. The length of that vector. For example, let's say if I am saying n equal to 7, okay, so this will be signal and sig a, then STD logic vector, and then it could be 7 down to 0. So it is equivalent to we are having 8 STD logic type variables. So basically it will be like 2, 3, 4, 5, 6, 7. Sorry. Yeah, it will be like this. It will be like this. Okay. So here I can write this will be bit 7, and this will be bit 6, this will be bit 5, this will be bit 4, this will be bit 3, this will be bit 2, and this will be bit 1. And if we can add insert right, then it could be bit 0. Okay. So all are having u. All are having u. U, 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 u. All right, guys. So not, yeah. All right. So now instead of this, if I will have this signal B, and which is which is having initial value also, because we can have initial value also, right, at the same time. So here, let's say I'm giving initial value. Okay. So that is also acceptable as per this logic STD type. Okay. So here also I can give the value equal to, let's say, x x a1. So what is this, guys? What is this? So this is in hex actually. This is in hex. So what will be this in binary? Can someone tell me? What will be this in binary? In binary, this will be 1010 and 0001. Correct answer? So then this u will replaced with 1, 0, 1, 0, 0, 0, sorry, 0 and 1. You understood, guys? No response? You understood this or not? Tell me. Tell me if anyone have any doubt. Anyone have any sorry. Anyone have any doubt? Oh, so you asking why are we using old version? So you can go with the latest version, but as we are using very simple one, right? So latest version sometimes require more size. So that's why I suggested. And sometimes latest version may be paid also. Okay, so you can check. It's a suggestion, and that's a good suggestion. But you can check if you are able to go with the latest version. Okay, so yeah. Anyone have any doubt in this? It's clear, right? Right? No response? Clear? Now let me show this in the code. So here, uh, I can just use std underscore this vector, this vector, and uh, 7 down to 0. Okay, and then here I should put like 0 and 0 and 0. So let's see. Yeah. Anyone have any doubt in this? Now let's see uh, the assignment. I mean, this vector assignment. What are the possible assignment and how we can make valid assignments? Okay. So we have this declared sig A, sig B, and then we can have sig null, sig C also, right? And which is of STD logic type. Okay. So let's say we are having these three vectors. So I want to explain here how we can go with the assignments. Okay. So I want to explain here about the assignment. So you tell me, guys, can I do like this? sig C equal to sig A. And can I do like this? Sig, yeah, can you tell me, is this valid assignment or invalid assignment? Tell me. No response? No response? Okay. So if you see here LHS and RHS, so LHS, basically you are doing 1 bit, you are assigning 8 bit. So the bit count is not same in LHS and RHS, hence it's not a valid assignment. So you have to make sure you are assigning same size of bit. It could be one, it could be multiple, it could be maximum, but it should be same. Okay. Okay. So so now I will talk about the correct assignments. Okay. So let's say sig A can have a sig B. Okay. So that's correct. Why? Why? Because both are having 8 bit. All right. So both are having 8 bit. Clear, sir? Now sig A of 7 down to 6 is also legal with any of पार्ट सेलेक्ट. इसको हम पार्ट सेलेक्ट बोलते हैं, बट द विड्थ शुड बी सेम. 3 down to 2. So this is also valid because both are having 2 bit, 2 bit of 2 bit. Are you getting me, guys? Now sig of A of 4 can have sig B of 0, sig B of 0, and sig C can have a value but not full but part select. So sig A of any which is 6, which is 6. So anyone have any doubt up to here, you can ask. So here we are having 1 bit, 1 bit of 1 bit, and here we are having 1 bit of 1 bit. So tell me if anyone have any ask. Sorry, if anyone have any doubt. Handy. So this is no. Clear, sir? No response, guys. If you are not responding, then what is the meaning of joining the session? Okay. If you are acknowledged, that is also fine. All right. So let's see here. If I will do wait for 10 nanosecond, and in between of this, I want, let's say, sig of A can have value of sig of b. So let's see what tool will give. Let's see. So what's your expectation? So can you see here, expecting an expression of type std logic. Okay. So basically it's a type compatibility. It's a type compatibility. But if you'll do the part selection, for example, let's say if you'll do 0, so then what happen? Then what happen? Oh. So can you see? It's working. Why? Because earlier they were not having equal width, and now you can see the equal width in LHS and RHS. Makes sense, right? So should I show you other examples also from this, or you understood? Tell me. No response? You can unmute and tell, or you can comment. You understood
Sir, what was
about
the
this?
question?
Yeah. Yes, please. Yeah, Gargi, you were saying something. I cannot hear you now.
Sir, were you asking any question?
Huh? Sorry? You are on mute. Okay, let me go ahead if you do not have any doubt. So now next thing is, okay, let me ask a question, or you can note that as a homework. So for example, if I make both as a vector, or let's say I will declare a signal C. Okay, so let's say I will declare as a signal C. And now I will write here signal C and signal C. So first you tell me, is this a valid assignment or invalid assignment at line number 26? Sorry, signal B to C. No response? It's a valid assignment or invalid assignment? No response, guys. Then you
Invalid,
should
sir.
not. Huh?
Invalid, sir.
How it's invalid?
Sir,
How?
because B is like a vector of size 8 bits and C is. Oh, sir, I'm so sorry, sir. Okay, C is. Yes, sir, it is valid. Sir, actually, I thought that C is 1 bit value. Yes, sir, it is valid.
Okay. So if it is valid, my follow-up question is, after this assignment, what will be the value of C?
X, sir.
Oh, when you said X, so X is 1 bit. But if your variable is of 8 bit, you should answer in 8 bit, right? So you have to tell the 8 bit value.
Not sure, sir.
Hmm. So that is the homework. That's the question to you. You understood? Everybody understood the question? Everybody understood the question? So signal B and signal C are vector. I am updating 0th bit of that vector, okay, and I'm then making assignment. Then I want what will be the effect in the remaining 7 bits. So obviously the 0th bit of signal C will be X. But what about the remaining bits? So do you believe they will be still U uninitialized or they will become X? Tell me. That's the question. So what do you think? Okay. So note down this question as a homework and you can do more trials also. Okay. Surrounding to this. Okay. Let me go ahead and yeah, let me go ahead. Okay. So next thing is, so we have this array attributes also. So basically in this vector type, so let's say if you have declared this, okay, and and you are saying so std logic vectors, so array sorry, yeah, array attributes and respective uh, return value, respective return values. So what are those? Actually, so we have yeah, so we have this attributes and their return value. So you can use in this declaration, you can say sig A is left. So that will give the n value actually. That will give the n value. So n is 7. That will give the n value. This value 7. Okay. If you say sig A of right, so that will give the 0 value, which is the rightmost value. So here if you see in this, so this is the left and this is the right. Okay. That's why you're getting the 7 and 0. Okay. So now you can also get the whole vector length. So sig A of length. So that will give the n plus 1 value because it's a 0 to n. So you will get the n plus 1 value, which is 8. And if you are saying range, so sig A's range. Can someone tell me what's the expectation here in range, what it should give? No response? So in the range, the exact range you should get. Okay. Or now one more question I have, guys. So here in the right side, I directly mentioned 0. So one more homework question I have. If instead of 0, I will write 3 here, I will write 2 here. So what happened? Is this declaration valid or invalid? Tell me. You understood the question, right? I mean, it should start with 0 only, or it can have other value also. No response? Huh? No response? So you can see here, it's working perfectly. So it is not like that it should be 0. It can be any value, right? So that's why we can write here M. Okay. So you can write this as a M also. And here you can put, instead of this 0 value, you can put M value. Okay. All right. And then this N plus M maybe will change. So, so you can say, so can we say N minus M plus N minus M? Let's say 7. Let's say, can we say N minus M plus 1? Can we say this, guys? We can say, right? This we can say is uh, N down to M. Clear, guys? No response? No response. Clear? So can you make some more trials as I did at my end, either in Modelsim or in Vivado, Quartz Prime, and this EDA anywhere? Can you please do? Okay. And let me give this code into the comment section directly. You can get that. So can you play around this, guys? As a homework, no response. So anyone have any doubt up to here, guys? So what I want from you as a homework, here I want you should use array attributes instead of writing 3, 4, instead of declaration. So I want you should use array attributes. Clear, sir? Then we'll go for the integer, signed, unsigned, enumeration, data type, array, and dot 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 dot. Okay. All right. So anyone have any question? You can ask. So you can go through, you can make some trials, you can do example, and you can go through the signed, unsigned, and that integer, and that enum data type. All right. So anyone have any doubt, you can ask. Else you may leave the call. Please ask if you have any question. Nothing? So Kesav, you are getting whatever I'm explaining? Deep? Chaliye, all right. So if you do not have any doubt, you may leave the call and maybe we'll see tomorrow and you can do your homework. All right. Thank you, everyone. Bye.